These are some good, decent aerodynamic problems. Please see this. This is a pulley, mass m1, radius r1. This pulley is wrapped with a string. A string is wrapped around this pulley, and this pulley is left free to roll down. I mean, when you leave it, it will start unwrapping and it will fall down. Tell me what will be the acceleration of the center of mass of the pulley? What will be the angular acceleration? Or also find the tension in the string. Kariye, simple question. Find the tension in the string. The pulley is falling down, unwrapping.
Pulley is a disc.
Disc. Mass and radius are. Solid disc.
mr square by 2.
Will mg be acting as a force on it? Yes or no?
Yes, sir.
Okay. Any other force you can tell me? There will be tension here. T. Any other force you can tell me? There is no other force. I am assuming the acceleration of the center of mass to be ACM acceleration, and the angular acceleration is alpha cm.
So clockwise zero.
Clockwise level. And now, if I write the equations for translational motion, mg minus t, I shift all the forces to the center of mass, and I write the equation mg minus t is equal to ma1. Have you understood this equation? This is for the translational motion of the disk. Everyone clear? Now for the rotational motion, net torque about the center of mass, I am choosing clockwise direction to be positive. Net torque, Kritika, you tell me what will be the torque due to mg?
Zero.
Zero, because it is passing through that point जिसके about हम torque निकाल रहे हैं, center of the disk. Now, there is another force. Yes, Mayank, you want to ask something?
सर हम यदि इस केस में हम सर t माइनस सर यदि हम लिखते हैं कि सर एक्सेलरेशन को एक वेक्टर क्वांटिटी में लिख देते सर हम ऐसे भी लिख सकते थे t माइनस mg इज इक्वल टू macm सर acm वेक्टर लिख देते
तो कोई बड़ी बात रॉकेट साइंस नहीं थी उसमें
सर वो रॉकेट साइंस नहीं सर पर यदि हम उसका जब टॉर्क लिखते सर
बेटा यू चूज एनी डायरेक्शन पॉजिटिव एंड यू राइट एनी डायरेक्शन में पॉजिटिव लेके और किसी भी डायरेक्शन को लिख दीजिए इक्वेशन रिमेन्स द सेम लेट मी इलस्ट्रेट इट टू यू लेट मी से t minus m1g is equal to mass into acceleration को आप क्या लिखना चाहते हैं मैम
एक्सेलरेशन वेक्टर लिख दो सर वो बाद में नेगेटिव आ जाएगा
नहीं बट वी नीड टू बात तो वही होगी ना अब उसको आप आंसर को वेक्टर फॉर्म में ही लिखेंगे या आपको मैग्नीट्यूड बतानी होगी फाइनली सो आई एग्री आप वेक्टर फॉर्म में ऐसे लिख सकते हो एसीएम वेक्टर बट जब भी आप उसकी वैल्यू रखेंगे ACM या आप उसको कुछ तो you have to put it with proper sign and you will realize you will put a minus sign here and you will get m1 into minus ACM because you have chosen upward direction as positive and if you multiply this whole equation by minus you will again get back the original equation this. I know you knew that. I know that also. Now let's come back. 1 minute. Kunal, Dhruv, Kunal, you have to tell me the equation for the rotational motion of the disk. You have to tell me there are two forces. Mg is going to produce zero torque about the center.
Sir, Mg को center के through pass करेगा तो उससे
torque is zero. अब बची tension.
Tr is equal to I alpha.
Yes, perpendicular distance is r. Therefore, T into r. T into r is the torque. Clockwise or anti-clockwise? Clockwise positive ले रहे हैं हम is equal to I alpha. Alpha हमने पहले से ही clockwise assume किया हुआ है. Please see here. So I'll put it as positive. I कितना होता है disk के लिए?
mr square by 2
into alpha. Now please tell me how many equations do I have right now? This is one rotational motion equation. This is the equation for translational motion. I've got two equations.
And three variables.
Three variables. How do I get the third equation?
At the point of contact.
Yes, the point of contact. All of you please pay attention. All of you have to understand this. Very, very important. Next question will be based on this and you might get stuck. So please learn this. Let me call the point of the string to be 1 and the point on the disk to be 2. This point is 2 and this point is 1. Please see this. Point 1 is on the string. Can you tell me what is the acceleration of this point of the string? This point. Tell me. Zero. So every point on the string, the acceleration remains. Vertical acceleration is 0. So acceleration of point 1, A1 is how much? 0. Acceleration of point 2 can be found by superimposition. Can anyone tell me how do I find that? Due to translation, it will be ACM. Due to translation, it will be ACM. Downwards.
Alpha.
And due to rotation, it will be upwards. In how much?
Alpha.
R alpha C.
Actually, it is alpha cross R. V is omega cross R. But वो अगर हम proper direction लें तो simple वाले cases में R alpha चलता है R omega. Now, so the net acceleration of point 2 will be given by ACM minus R alpha. So I have both the accelerations have to be equal because there is no slipping between the string and the body. Therefore, 0 should be equal to ACM minus R alpha. Let's do a better question than this. Yes.
सर एक डाउट नहीं है सर, आप एक चीज आपसे पूछें कि सर क्या हमें डायरेक्शन पूछते मतलब सर वेक्टर फॉर्म से करना चाहिए ऐसे करना चाहिए क्वेश्चन?
बेटा आपको ऑलवेज इन क्वेश्चंस में आप सोच रहे हैं कि हम डायरेक्शन का ध्यान नहीं रख रहे हैं.
सर नहीं ध्यान रख रहे हैं सर, कभी कभी क्या होता है सर, अभी तो ठीक है सर, तो जब कॉम्प्लिकेट हो जाता है सर कहीं ना कहीं डायरेक्शन हो जाता है सर,
मैंने भी पहले वही
पर सर वो लेंथी हो जाता है, डायरेक्शन देखते देखते आई जे के को मल्टीप्लाई करते करते काइंड हो जाता है. सर आपके हिसाब से क्या करना है?
बेटा मयंक जब आप सुनिएगा, जब आप 10 गुरुओं से पढ़ते हैं सेम चीज तो आपको ये कंफ्यूजन उठता है. मैंने आई गिव यू अ वेरी गुड एग्जांपल. मैंने रे ऑप्टिक्स पढ़ी रेसनिक हॉलिडे से, एनसीईआरटी टेक्स्ट बुक से और एक करस्पॉन्डेंस कोर्स. एक में डिफरेंट साइन कन्वेंशन दिया हुआ था, एक में डिफरेंट साइन कन्वेंशन दिया हुआ था. एंड सिंस आई वाज डूइंग सेल्फ स्टडी तो मुझे वो इतना मेजर कंफ्यूजन हो गया था कि मुझे रे ऑप्टिक्स से डर लगता था. प्लीज अंडरस्टैंड दैट. Same way, what you are talking about right now is, I don't see any complication whether you do it with vector approach or you do it like this, the way we are doing it. We are taking care of vectors, we are writing positive and negative sign convention, उसी के accordingly हम sign use कर रहे हैं. बट आपका जो कंफ्यूजन है, आपके दिमाग में किसी एक टीचर ने एक पर्टिकुलर वे में क्वेश्चन सॉल्व करने का तरीका डाला होगा, अब आपको ये थोड़ा सा अनकंफर्टेबल हो रहा है और ये लीड्स टू अ chaotic situation. So I request you, थोड़ा सा क्लियर रहिए और जो मैं बोल रहा हूँ उसको अच्छे से समझ के, whether you use that or you use this, it doesn't matter. We are being consistent and logical. We are not anywhere saying we are not taking care of direction. In when you are solving questions and you have to tell the numerical values, you cannot keep using that vector arrow in all the equations and solve them. Please understand that. If you can do that, just show me the next question. उसमें आप करके दिखाइए कि आपको आंसर आ गया. Then I'll understand what you are trying to say is logical. Are you clear what I'm saying? Let's move now. Ready. Next question is going to be one step better than this. And again, it is an Irodov problem. So there is no high-tech funda in the problem. It is just a little extension of this same situation. This is a circle of radius r. This is a disk of mass and radius r. Mass is m1, radius is r. Again, there is a thread which is wrapped around it and it is hanging from the ceiling. From the center of this disk, there is another string hanging and it is wrapped around another disk of mass m2, radius r2. This is also an Irodov problem. Please see this. Mass m1, radius r1, mass m2, radius r2. And now I leave the whole system free from rest. Both the disks will start unfurling. They will unwrap and fall down. You have to tell me the tensions only, nothing else. You have to tell me the tension here, T1, and you have to tell me the tension here. Please try to do this. Let me see who can solve it fast. Just write the correct equations, I'll be happy. Pay attention here. Just see the method. I want you to understand the concept involved. Yes, this time I want people to reply. Somebody, please tell me what are the forces acting on this sphere. Is mg acting or not?
Yes, sir.
Sir,
M1G.
M1G, sir.
M1G. And there is this tension T1 and there is this tension T2 acting downwards, yes or no?
Yes, sir.
Yes. On this, there is this tension T2 upward and mass M2G. Are you clear? Okay. Now let me assume that the acceleration of the center of mass of this is ACM. Assuming that acceleration of center of mass is ACM or just A1. And angular acceleration is alpha 1. I am assuming this. And for this sphere, I am assuming acceleration of center of mass is A2 and angular acceleration about center of mass is alpha 2. Now, Kritika, please tell me the translational motion of the lower sphere. Please tell me the equation for the translational motion of the lower sphere. Fast.
M2G minus.
Perfect. I appreciate it. Good. The same thing for rotational motion of this sphere. Please tell me fast.
Sir, T2 R2 is equal to I alpha 2.
Yes. The torque due to M2G will be 0 about the center of mass. I agree. And the torque due to T2 will be tension into perpendicular distance. The perpendicular distance is R2. I agree. And I will say net torque. Net torque will be given by R2 is equal to I2, which will be M2 R2 square by how much?
Into alpha 2.
Alpha 2.
Yes, this is correct. I appreciate. Aishwarya, you have to tell me the translational and rotational motion of the upper disc. Fast. Translational.
So M1G minus T2 plus T2 minus T1
निकाल दिया
Even
is M1 A1.
हो जाए actually.
Correct. This is the translational motion equation. And rotational motion equation fast.
T1 R1 is equal to M1 R1 square by 2 into alpha 1.
I am impressed. Now, these four equations are easy to get. Any average child will get these four equations. There are 6 unknowns. There are 4 equations we have. We need 2 more equations. Is there any above average child who can tell me the remaining 2 equations? Who wants to attempt?
Sir, is it A1 is equal to R1
1 minute.
alpha?
1 minute. I want an answer. I don't want to be asked another question. Is it? So don't start with is it. Dhruv will be tested right now for the 5th and 6th equation. Let me highlight what we are trying to write. We are trying to write the acceleration, the equation for the point of contact. Let me assume this point of contact, this point on the string is called 1 and the point on the disk is called 2. Dhruv, please tell me what will be the acceleration of point 1? Point 1 is the point on the string. Huh? Yes, 0. Yes. And what will be the acceleration of point 2? Point 2 is the point in contact with the string point of the disk. Point 2 is the point on the disk.
A1 minus R alpha 1.
A1 minus yes. Due to yes, I agree. I appreciate acceleration due to translation will be downwards and it will be A1. And due to rotation, since it is clockwise, the acceleration will be R1 alpha 1 I think.
Sir, it's not coming out properly. आप थोड़ा सा बाकी लिख दीजिए.
Have you? Yes. मैंने थोड़ा टेढ़ा लिखा है इसलिए आपको ऐसा लग रहा है. So A2 will come out to be A1 minus R1. Now both are not slipping with respect to each other. Therefore, A1 minus R1 alpha 1 is equal to 0. This is the 5th equation we have now. Let's write the 6th equation, which is the point of contact here. This point is on the string and this point is on the disk. The point on the string I am calling as 4, point on the disk I am calling as 5. Yes.
Sir, it's A1 downward.
Yes, the acceleration, the center of mass of this disk is coming down with an acceleration A1. I agree. And the same acceleration is the acceleration of any point on this string downward. Yes. And therefore, the acceleration of point 4 will be equal to A1. I agree. Now, can you tell me what will be the acceleration of 0.5 by superimposition?
Sir, A2 downwards and R alpha R2 alpha 2 upwards.
Yes, due to translation A2 and due to rotation upwards, which is R2 alpha 2. I agree. So it will be A2 minus R2 alpha 2. I have assumed downward to be positive. And 4 and 5 should have same acceleration because they are in contact. So this should be the last equation. The 5th equation is A1. How many of you had written all these 6 equations correct on your own?
The last one.
Last one.
Sir,
ठीक है.
लिखिए नहीं.
Very good. Now, solving this will be done at home or after the